Okay, so I'm on the top of page 27 in your packet, and I want to just refresh our memory of two different types of triangles, special right triangles that you all have seen from geometry. The first special right triangle is 45, 45, 90-degree triangle, so our sides are the same, and our hypotenuse is square root of 2. With the 60, 30, 90 triangle, the side directly opposite of the larger angle of 60 is square root of 3. The side opposite of 30 degrees is 1, and our hypotenuse is 2. So those are just two special right triangles that you guys have seen from geometry in a review. Now we're going to use these special right triangles to find out what our sides are when our hypotenuse is 1. So notice in all three of these triangles, my hypotenuse is 1. As long as I have one angle and a side, I can figure out what my other sides are with trig functions. So if I'm trying to find out what this value is here, let's just call this x. If I'm trying to solve for x, x is opposite of the angle. So since it's opposite and I know the hypotenuse, using my SOHCAHTOA, something that's opposite and hypotenuse is going to be sine. So this is going to be sine of 30 is equal to x over 1. So, well, okay, so x over 1, that's just going to be sine 30 is equal to x. So if sine of 30 is equal to x, so it depends on what calculator you want to use. I can use an online calculator, plugging in sine of 30. So I'm going to say make sure that this calculator, oh sorry guys, alright, on my online calculator, make sure that, see how it says RAD? This needs to say degrees. For some reason, the default on this online calculator is always RAD. That stands for radians. You always, always, always have to click this so it says degrees, as long as we're in degrees mode. So I'm going to have sine of 30, sine of 30, close my parentheses, and I get 0.5 or equal to 1/2. So I'm going to have this value is equal to 1/2. So now I can either use Pythagorean theorem, x squared plus y squared is equal to my hypotenuse squared, or I can do my other trig identity. Now if I'm talking about my 30, 60, 90 triangle, I'm going to go back and compare it to this triangle. So across from 30 is 1, and my hypotenuse here is 2. So that means if my hypotenuse here is 1, then across from 30 has to be 1/2. Do you see how I divided by 2? Divided by 2 here, so the hypotenuse is 1. Divided by 2 here, so my side is 1/2. That means I could either use a trig identity or I could use this special right triangle and know that this is going to be square root of 3 over 2. So there's multiple ways to solve this problem. I could have used the trig function, or I can use this special right triangle. Now let's use this. This is my 45, 45. I know this angle is 45 degrees because my total, the sum of the interior angles of my triangle is 180. So 90 plus 45 plus 45 gives me 180. Now, here's my setup for this problem. Square root of 2 is my hypotenuse, and 1 is my sides. So if my hypotenuse is 1 instead of square root of 2, that means I must divide everything by square root of 2, because square root of 2 divided by square root of 2 would give me 1. So that means this side is going to be 1 over square root of 2. Don't leave radicals in the denominator. To get rid of my radical in the denominator, I'm going to multiply square root of 2 over square root of 2. This is going to give me the square root of 2 over 2. So then this side, since these sides are the same for a 45, 45, 90 degree triangle, that means this side has to be the same. Square root of 2 over 2. All right, let's go to this triangle. This is 60. That means this has to be 30 degrees. Well, these triangles are exactly the same. 30, 60, 90. 30, 60, 90. So directly across from the 30, I'm going to have 1/2. Directly across from the 60, which would be here, I'm going to have square root of 3 over 2. All right. Now we're going to find the sine of 30 degrees. So sine of 30 degrees is going to be opposite over hypotenuse. So that's 1/2 divided by 1, which is just 1/2. Cosine of 30 degrees, that's adjacent over hypotenuse. So square root of 3 over 2 divided by 1 is just going to be square root of 3 over 2. The sine of 45 degrees, so I can either choose this one or this one, doesn't matter. So the sine of this 45 degrees, sine is opposite over hypotenuse, so it's going to be square root of 2 over 2 divided by 1. So that's going to equal square root of 2 over 2. The cosine of 45 degrees, it's going to be the same thing, because adjacent over 1 is going to give me the same. Square root of 2 over 2 divided by 1 is equal to square root of 2 over 2. All right, so now to this triangle. Sine of 60, sine of 60 degrees, opposite over hypotenuse. So square root of 3 over 2 divided by 1 is just square root of 3 over 2. Cosine of 60 is the adjacent over the hypotenuse. So that's going to be 1/2 divided by 1, which is just 1/2. Okay, so now let's take these triangles and put it in a coordinate plane. So this is our coordinate plane. We have our y-axis and we have our x-axis. So what would an x-coordinate be for this triangle and a y-coordinate be for this triangle? Well, this is our 30-60 triangle with a hypotenuse of 1. So going back up, this is exactly the same as this triangle. So that means x is equal to square root of 3 over 2. And y is equal to 1/2. So this point here would be square root of 3 over 2, comma, 1/2. My x portion and my y portion. Notice that I'm in quadrant 1 here. So since I'm in quadrant 1, it makes sense that my x is positive and my y is positive. All right, so this lovely circle is what we call a unit circle. So we're going to be talking about this tomorrow. The key thing that I want you to take away, so we're prepared for tomorrow, is the radius of this circle. So notice we have two triangles here, and the distance is 1. The distance is 1. So if we create a circle of all these triangles, the radius is going to equal 1. So no matter where we draw our triangle, the radius in the unit circle is always going to equal 1. And we're going to use that to solve for our sine and cosine.